All right, so really, this question is a little bit more challenging simply because it has that negative sign. But if I take a look at my index of my root, and I'm trying to simplify, the index of my root is 3. So I have to try to break up 3 components, 1, 2, and 3, because they're really either constants or variables, so that my exponents are divisible by 3. So now I'm just going to play around here. Negative 2 to the power of 3 is negative 8. So that is going to be kind of important. That is, the cube root of negative 8 is actually negative 2. So that's how I would start this question off. So first thing I'm going to do is I'm looking for cube root. I'm going to take care of the constant first. I would say this is negative 8 times 2, and then a. I'm going to make sure that my exponent for a is divisible by 3. So a to the power of 3, it just so happens that my exponent is 3, which is divisible by 3. B to the exponent 8. I need to make sure that my exponent for b is divisible by 3. Well, 8 isn't divisible by 3, so I'll have to split it up. And I'm going to split it up into b to the power of 6 times b to the power of 2. So I'm just going to underline everything that I can take the cube root of. I can take the cube root of negative 8. I can take the cube root of 4 to the power of 3. I can also take the cube root of, not b squared, can't do that, but I can take the cube root of b to the power of 6. So I'm going to reorganize this by writing it as b cubed, the cube root of negative 8, a to the power 3, b to the power 6, times the cube root of 2 times b squared. I can evaluate everything in that first radical. The cube root of negative 8, a to the power 3, b to the power 6 is negative 2ab squared, times the cube root of 2b squared. And often this will just be written like this. All right. So that was fun, and that was simplifying. So simplifying, we just really need to make sure that our index, or we split up our radicands into the exponents that are divisible by our index of our root. Now, we're going to change the following into mixed radicals. So we're just going to use the multiplication rule just in reverse, right? So what are we going to do is we are going to, if you notice, we have two quantities, 2x times the square root of 5x squared. That's what this says. So we have a mixed radical because we have the coefficient in front and something under a radicand. We want to move everything under a radicand. So I would write this as, how 2x is equal to the square root of what number? Well, it's going to be 4x squared. Now, how do I know that, right? So really, this is what I do. I take 2x and I square it, and that creates 4x. And this implies the square root of 4x is equal to 2x. So I reverse engineer 2x so that it has the index of 2 for a radical. So instead of writing 2x, I write the square root of 4x squared times the square root of 5x. Now, if you notice, I left off my index of 2. It is implied that it is 2. So now I'm just going to put it all underneath one radical, 4x squared times 5x, and then I'm going to combine what's underneath to say that this is going to be 20 times x cubed. 4x squared times 5x is 20x cubed. All right, not so bad. Well, maybe a little bad. So allow me to try to pick apart what's going on here. Now, I'm looking at this expression and I can see how people get confused. But it's really 12v squared times 2u, or times the square root of 2u. This, including the 2, would be outside the radical. So what am I going to do? I fundamentally ask 12v squared is equal to this, to what? Well, what I'm going to do is I'm going to say 12v squared, and I'm going to square that, and that is going to be 144v to the power of 4. If you want to know, it's 12v squared times 12v squared. I'm going to organize the constants together, 12v times 12v, and this would be v to the power of 4. And that is 144v power 4. Anyways, from this simple fact, I can say that the square root of 144v to the power of 4 is equal to 12v squared. So instead of writing 12v squared, I can simply write the square root, simply, air quotes, 144v to the power of 4 times the square root of 2 to the 2u. Now, I believe I'm going to make this abundantly clear here. This is b to the power of 4, and that's u. These are two different variables. So when I'm going to multiply them out, it's going to be one. They have the same index, which is 2 for my radicals. So now I can simply move them underneath the same sign, or underneath the same radical. So that's 144v to the power of 4 times 2 to the times 2u. The indexes were the same, so I'm able to move them under the same radical. So I am just going to reorganize. That's 144 times 2 times u times v to the power of 4. The reason why I organized u before v is because in the alphabet, u becomes before v. So often it does in polynomials. So 144 times 2 is 288 u v to the power of 4. I believe I have one more example. So, just going to take this. And there are 3 components to this. And if you're more clever than me, maybe you can find a shorter way. And there is a shorter way. But I know that 6 squared is equal to 36. This implies, I should write it this way, the square root of 36 is equal to 6. Why am I talking about this? Well, the index of my, I'm just going to maybe rewrite it in my own hand so that I actually understand what's going on better. That's how I would write this. My index for my radical is 2. So I'm going to deal with square roots. So naturally, when I'm dealing with square roots, I'm going to look at the inverse. So 6. 6 is equal to the square root of 36. So to do that, to derive that, I can say 6 squared is equal to 36. So this implies that the square root of 36 is equal to 6. Fair enough. Now x squared. Now x squared is equal to x to the power of 4. So this implies that the square root of x to the power of 4 is equal to x squared. So instead of writing x to the squared, I could write the square root of x to the power of 4. Now y cubed squared is equal to y to the power of 6. So this implies that the square root of y to the power 6 is actually y to the power 3. So instead of writing 6, I could write the square root of 6, or square root of 36. Instead of writing x squared, I could write the square root of x to the power of 4. And instead of writing y to the power 3, I could write the square root of y to the power of 6. Well, all right, let's do that. And I'm just simply replacing my quantities 6, x squared, and y with what I have highlighted in yellow, green, and purple. I'm going to get rid of my index of 2 there, simply because there's a lot of exponents going on. So everything here is a square root, so it has the same index. I'm just going to multiply through here, so 36 times x to the power 4. That is, I'm going to bring every radicand under the same radical. And that's what we would have here. So it might take some organization here. So to show my work, I'm going to write 36 times 7 times x to the power 4. Do I have any other variables of x? Sure, I have x. Right, so I've taken care of that, taken care of that, taken care of that, taken care of that. And then y squared times z. Now 36 times 7, I don't know what that is. And that's 252, x to the power of 5, y squared remains as it is, times z. And there we have it. I just simply multiplied and consolidated all the exponents. I wish you all the luck. This is a little bit heavy, and if you